अब फ्लाई करना.
एक सेकंड. Hello. Hello students, very good evening to all of you, and really sorry for a small bit of I got late. There were some technical issues, and a very good evening to all of you. So many students are already there. So students, we have just few days left for KCET examination, right? 16th we have chemistry. So in today's video we are going to revise the main important chapters, some important concepts, formulas, everything. Okay, so students, first of all, everyone, hi, hello, everyone, good. Hope all of you are doing well. Yes, started here, those are waiting. So just a minute, please do not worry. We have already started now. Okay, so let's get started without wasting even a single time. We are like on a very I can say on a very just 2-3 days are left for the exam. So let's be serious and let's start with full confidence and with full juice. Okay, I want all of you to give a comment that you are ready to start the session. Just put a thumbs up and just tell me you are ready. Okay, yes, always yes. Okay, so just a minute. Let's get started, students. Here, so we will be discussing all the important chapters, all the important concepts. Okay, so with this, so first we will be starting with physical chemistry. Okay, physical chemistry, I'll be telling you the important chapters. So if you do these chapters, in this video I'm going to discuss physical chemistry and inorganic chemistry. Okay, so all the important formulas, concepts and questions will also be discussed. Okay, so please don't worry. On this we have these important chapters in physical chemistry that you need to focus on. What all chapters we have? We have solutions, electrochemistry, chemical kinetics, thermodynamics, equilibrium, some basic concepts of chemistry and structure of atom. Okay, if you do these chapters, you will definitely be able to get a very good mark, right? So yes, definitely it will help you. Okay, so yes. Okay, so Sai, so Niket, Gagan, Chandan, Nitin, Rachit, all of you, hi everyone. Okay, so let's get started here. Okay, so first of all we'll start with the solutions chapter. Okay, so what all topics you have to focus in this particular chapter, let me tell you. You have to focus on types of solution. There can be examples of gaseous solution. Okay, what will be like, which is a gaseous solvent, which is a liquid solution, examples can be there. Then concentration terms, we have molarity, molality and mole fraction. These are the three important concentration terms that we have to focus. Henry's law and Raoult's law, all we will be discussing. Ideal, non-ideal solutions, colligative properties and abnormal molar mass. Okay, so these are the concentration terms that we have. Okay, so you can see here. Yes, so we have this ideal and non-ideal solution. We have to focus on positive deviation, negative deviation and azeotropes. Okay, and in colligative properties we will have relative lowering of vapor pressure, elevation in boiling point, depression in freezing point and osmosis. Okay, so okay, let's get started here. First of all, in concentration terms, what exactly you have to focus in mole fraction. Okay, mole fraction is important. Here, you know, in relative lowering of vapor pressure, mole fraction is used. So please understand the formula of mole fraction properly. Number of moles of the component divided by the total number of components. Okay, so for example, if I have suppose I have two components. Okay, A and B, number of moles of A and NB is the number of moles of B. Then what will be the mole fraction of A? That will be equal to Na by Na plus Nb, right? That is your mole fraction. Okay, clear? Okay, so next we will, this is how you have to find mole fraction. This is important. Coming to the next topic, that is molarity. Again, we know where we have to use molarity. In osmotic pressure, colligative properties, we have molarity, right? What's the formula of molarity? W2 by M2 into 1000 by volume of the solution in ml. Okay, W2 by M2 into 1000 by volume of the solution in ml. Clear? Next, molality, it is used in elevation in boiling point and depression in freezing point, right? What's the formula for molality? W2 by M2 into 1000 by mass of the solvent. Okay. Okay. Next, coming to, so now let's talk about Henry's law. Henry's law question is important. So pressure of the gas is equal to Kh into mole fraction of the gas. Okay. Now here, what is the importance of Kh? Kh is inversely proportional to solubility. So here how questions are asked also I'll tell you. See, suppose 5 gases are given or 3 gases are given, A, B and C. Their Kh values are given to you, right? So the one whose Kh value will be maximum will be least soluble, okay? And the one whose Kh value will be minimum will be highly soluble. Clear? So we have to focus on Kh value and it is inversely proportional to solubility. A similar question has been asked in the past. Okay, so that is why I am focusing on this one. Please remember the relation between Kh and solubility. Okay. Okay. Now there is one more relation about Kh and temperature. Kh is directly proportional to temperature. If temperature will increase, Kh value will also increase. There can be a question like this: which of the following factors will affect Kh? So always remember, Kh will be affected by temperature only. Okay. Now moving to Raoult's law. What is Raoult's law formula? P total is equal to x1 P1 naught plus x2 P2 naught, where P1 and P2 are what? P1 naught is the pure pressure of 1 and P naught 2 is the pure pressure of 2. Okay, and x1 and x2, x1 is the mole fraction of 1, x2 is the mole fraction of 2. Now here a question may also be asked about the gaseous mole fraction or mole fraction in the vapor phase, right? So what I will have, y1 will be equal to P1 by P total. I hope this is visible. Is it visible? Y1 is equal to P1 by P total and y2 will be equal to P2 by P total. Okay. Clear? Okay, so just let me take it aside. Okay, clear students? Okay, Darshini, this session we will be doing it for 2 hours. Okay, we will be completing. So those who are asking for organic chemistry today, students, in this live session I am covering physical chemistry and inorganic chemistry. Tomorrow I will be having a live session where I will be doing organic chemistry. Okay, so we will be focusing on physical and inorganic today. Clear? Okay, let's get started here. Coming to ideal and non-ideal solution, this is another important concept. Here what will happen, questions will be asked from the example. So what you have to do, simply you have to remember ideal solutions examples, non-ideal solutions example, ideal solution properties, non-ideal solutions properties. Okay, so we will have this one, delta H mix will be equal to 0 for ideal solution, and for non-ideal solution this is not equal to 0. V mix is equal to 0, delta V mix is not equal to 0. It obeys Raoult's law, does not obey Raoult's law. And here we have AB interactions is equal to AA and BB interactions. Here we have AB interactions is not equal to AA and BB interactions. Now here a question can be asked like, which of the following is a property of ideal solution, or one example will be given. For example, N-hexane and N-heptane, which properties are there? So you should be able to know what is the property of ideal solution and what is the property of non-ideal solution. So please take a screenshot of this table and you have to remember this. Okay, clear? Can be. Okay, next we will move to, yes, notes will be provided. Top 10 edits, we will be solving questions. Please don't worry. First let us recap the concepts, then we will definitely go and solve the questions. Next we will have positive and negative deviation. Okay, in positive deviation what happens, the AB interactions are weaker than AA-BB interactions. Okay, positive deviation, AB interactions will be weaker here, and here negative deviation, AB interactions are stronger than AA-BB interactions. Okay, next P total here will be greater than P1x1 plus P2x2, and here P total will be less than P1x1 plus P2x2. Okay, AB interactions are equal to AA and BB. Already I have told this point. Example. Again, focus more on example. This is from where questions will be asked. Okay. Previously, many questions have been asked from this examples type. So please remember at least examples of positive and negative deviation. Okay. Okay. Clear? Okay. Now we have ethanol and acetone, CS2 and acetone in positive deviation, phenol and aniline and chloroform and acetone in negative deviation. Okay. Next, moving forward, we have the graph. This is just, you should know the graph, not very important. Okay. Now coming to azeotropes. What are azeotropes and what are the type of azeotropes we have? Azeotropes are those solutions where the solution, means if you are mixing two solution A and B, they will boil at a single temperature and you cannot separate them by distillation. So that type of solutions are called as azeotropic solutions. Okay, and we have two types of solution, minimum boiling azeotrope and maximum boiling azeotrope. So here also you should remember the example. So minimum boiling azeotrope shows negative deviation and maximum, sorry, one second. Yes, maximum boiling azeotrope shows negative deviation and minimum boiling azeotrope shows positive deviation. That means what? Suppose, see, in maximum boiling azeotrope, if you have taken A and B, okay, the boiling point of A and B will be great, means the boiling point of the solution of A and B will be greater than the boiling point individually of A and individually of B. Similarly, for minimum boiling azeotrope, it shows positive deviation. That means the boiling point of both of A and B will be less than the boiling point of A and B individually. Okay. Okay. Now we have here examples. You can see the examples. Nitric acid and water. So always remember the examples for positive deviation and negative deviation, maximum boiling and minimum boiling. Okay, the examples nitric acid plus water, and here example is ethanol plus water. The percentage is also important. 95% water, 5% ethanol, 68% nitric acid and water is 32%. Okay, these are the important examples that you should remember. Okay. Now we have here colligative properties that you should be knowing. From here questions have been asked repeatedly. So please let us, if you are making notes, please make notes of these formulas. We have how many colligative properties? We have 4 colligative properties. Okay. The first one is relative lowering of vapor pressure. According to this, what happens in a solvent? Okay, if you add some solute, okay, if you add some solute, the vapor pressure of the solvent will decrease. Clear? What is relative lowering of vapor pressure? When you add some solute to a solvent, the vapor pressure of the solvent will decrease. Okay. Now the vapor pressure, if it is decreasing, then how much it is decreasing, that we have to calculate. So that is called as relative lowering of vapor pressure. Now P naught is the vapor pressure of the pure solvent and P is the vapor pressure of the solution divided by P naught. Okay, P naught by P minus P naught is equal to XB, where XB is the mole fraction of the solute, that is equal to NB by Na plus NB. Okay. Now formula for dilute solutions. In dilute solutions, what happens? You can ignore this NB and we will have NB by Na. Now remember, whenever we will have the solutions, okay, whenever we will have questions from relative lowering of vapor pressure, we have to use this formula only. Okay, you have to use this formula. Next we have elevation in boiling point. So what does that mean? When I add a solute, the boiling point will increase, right? So delta TB is equal to KB into M. KB is your constant and M here is molality, W2 by M2 into 1000 by M1. W2 is the mass of the solute, M2 is the molar mass of the solute, 1000, and M1 is the mass of the solvent. Okay, what is W2? Mass of solute. What is M2? Molar mass of solute. Okay, molar mass of solute. Then what is here M1 or M1, I can write W1, mass of solvent. Mass of solvent, and we have 1000 here. Okay, so AK, do not worry for organic. I will be coming live again tomorrow to do organic. We will be solving all the important questions tomorrow for organic. Okay. Okay. Now we will have next, that is depression in freezing point and osmotic pressure. So depression in freezing point, we have the same formula Kf into m, where Kf is your freezing point constant, or you can say cryoscopic constant, and here it is molality. Now here osmotic pressure is again important, pi is equal to CRT. Here the formula is different. C stands for molarity and not molality, okay, molarity. So molarity's formula is W2 by M2 into 1000 by volume of the solution into R into T. What's the value of R you should take? R should be equal to 0.083 liter ATM mole inverse Kelvin inverse, and T should be in Kelvin. Okay, clear? Okay. Next, okay, we will have now something called as abnormal molar mass. Okay. Now see here, sometimes what happens, certain particular solute, okay, they will dissociate or they will associate after they go into the solution, okay. So we need to calculate the degree of association or degree of dissociation, okay. So for degree of dissociation, the formula of alpha is equal to I minus 1 divided by n minus 1. What is I here? I here is Van't Hoff factor, okay, Van't Hoff factor. Okay. And n is what? Number of ions after dissociation. After dissociation. This is important formula. And how to calculate I? I is equal to number of ions after dissociation divided by number of ions before dissociation. Okay, that is the value of I. Now, if the particles are associating after entering into the solution, if they are forming association, okay, then we will get I minus 1 divided by 1 by n minus 1. Clear? Okay. So now students, we have revised all the concepts from solutions chapter, and now let's have some question practice. Okay. Yes. Can you all try this question? Please all of you solve this question and tell me the answer. Yes, Nirmala, we are doing example, do not worry. Please solve this question. I have given you the formula as a hint also. Okay, hint is given. You need to try to solve this question. I hope it is visible to all of you. Let me be aside. Yes. Yes, please students, solve questions now. I cannot find anyone answering the question. Students, please stop your chat and solve the question and give me the answer. Yes, Arohi is the first person to answer. Yes, Arohi, you are absolutely correct. It is option number D. Students, if you just put down here comments, you are scared and all, that will not work. Please sit focusedly and see the video and try to answer the question, try to solve the questions with me. That will actually help you, right? So please do not panic and please sit with full focus, concentration, attention, and try to solve questions with me. Try to make notes of the things that I am giving you. That will help you to really do good in the exam. Okay, so now we can see that, see, the rise in the boiling point of a solution containing 1.8 gram of glucose in 100 gram of solvent is 0.1 degree Celsius. The rise in the boiling point means delta TB is 0.1, right? Now Kb value we have to find out. Okay, next molality is what? Given mass by molar mass. So 1.8 gram is the given mass. Molar mass of glucose, all of you should know, it is 180 into 1000, right, divided by 100. So if I just cancel, it will become 18 by 180. So that will become 10, 1 by 10. If I multiply 10 this side, it will become Kb. So 1 will be the answer. Yes. Yes. Those who have taken D, all of you are correct. Okay. Next. We'll move to the next question. Which of the following aqueous solutions has the highest freezing point? Very, very important question. All of you please try. Ajay, I will be uploading the PDF in the WhatsApp channel, so please don't worry, you will get it in the WhatsApp channel. Yes, Rahul, you are also correct. Next question, please all of you answer. Be very, very careful. This is very important question and a tricky question. Yes. B. No, all of you are wrong here. I can't find even a single student answering correct. Yes. See here. Now see, I am asking where the freezing point will be highest. Okay, what's the depression in freezing point formula? Delta TF is equal to I into KF into M, right? Now you can see here all the M values are slightly different, right? We have to then calculate I and M value. You have to calculate for each of the option I and M value. So for here I NaCl for option number A, what's the value of IM? I is equal to 2 and this is 0.01. So I will get 0.02. Then B, option number B, I have again 0.01 and here I value will be 3. Why? Because I am getting 3 ions here. So 3 into 0.01, 0.03. Next, I have sucrose. There is no I value is 1 only. So it will be 0.1. Next D, you will see I will get 0.2. Now see, these are all the depressions in freezing point. So if I have first option, you can see the depression is 0.02, here the depression is 0.2 and here the depression is 0.1. So you can see option number 1 will be suppose here where I have 0.02 depression. Option number B will be 0.03, slightly after that, right, 0.03. Option number C will be 0.1, greater than that. Okay, and option number D will be highest. 0.2. So where the depression is maximum, there the freezing point will be minimum, right? The freezing point has gone down by this much. You have to see the freezing point is highest in option number A here. So that is why option number A. I hope this is clear. Question option number A, is it clear to everyone? If the option number A is clear to everyone, yes. Option number A, students, if it is clear, just put a thumbs up for me. D, those who are saying it is wrong, dear. You see where it is 0.2 here, right? The depression is 0.2, the highest one. So that will have the lowest freezing point. Question is asking you the highest freezing point. So if I order them according to the freezing point, then the highest one will be A, okay? Then I will have B, then I will have C, and lastly I will have D. If it is clear, please put a thumbs up, then we'll move forward. Okay, next. Okay, next question. 0.06% of W by V aqueous solution of urea is isotonic with. It will be isotonic with. What is the formula? When does a solution becomes isotonic? It will be isotonic if pi 1 is equal to pi 2. Right? If the osmotic pressure of one solution is equal to the osmotic pressure of the other solution, then it will be isotonic to each other. Right? Now you have to find out that I have been given with 0.06% W by V aqueous solution, 0.06%, and of urea is given. So where does which option will have the same concentration? What is the C value for the given this one? 0.06, that is your given mass. Urea is 60 divided by 1000, and here the volume is percent means volume is 100, right? So it is 0.6 by 60, or I can say 0.01. The concentration is 0.01. Which option will have concentration of 0.01? You can see directly it is in option number D. Right, option number D. Why C? If you see option number C, okay, you have to calculate the molarity. So 0.06, what is the molar mass of glucose? 180 into 1000 by 100. Okay, so we can cancel. So I will have here 6.01 and 6.63 18. So you see it will not give you 0.01. I need that the concentration should be 0.01. No, those who are saying C, it is completely wrong. Okay, the answer has to be option number D. Concentration has to be equal 0.01. Okay, Rajiv Kumar. Okay, Rajiv Kumar, see if you have any problem with the Comet K test tube, test series, you have an email ID. Please just put your mail. Okay, so Rajiv, you can put your contact number and your phone number, name, everything, mail address to this mail ID. Our team will contact you. Okay, so please do it today so that tomorrow they can call you back. Okay. Okay, now let's move to next thing, electrochemistry. Okay, what all topics we have to focus in electrochemistry? Nernst equation, electrolytic cell, products of electrolysis, conductance of electrolytes, and then lastly we will be focusing on batteries. Okay. Okay, for going for Nernst equation. Nernst equation, first of all, what is the need of Nernst equation? It is used to calculate the EMF of a cell. Okay, when battery is there, how much voltage will that battery provide? That is why the Nernst cell is used, or Nernst equation is used. So Nernst equation can be for two things. You can do it for only electrodes if you just want to calculate the electrode potential, or you can use it for calculating the cell EMF. Right. So let us see the formula here for electrode. If it is there, the formula is like this for electrode. E of the electrode is equal to E naught of the electrode minus 0.059 by N log of 1 by Mn plus. Okay, so that is the formula. You can use this formula. Please note it down. Okay, please note it down. Okay. Yes. Okay. Next, moving to cell. For this one, if you see, this is your nickel. One cell notation is given. How will I write the Nernst equation for this one? It will be E of the cell will be equal to E naught of the cell minus 0.0591 by N. What is the number of electrons used here? You can see 2 electrons have been lost here and 2 electrons have been lost here. So I can say 2 log of product divided by reactant. So on the product side I have nickel concentration, okay, divided by reactant is Ag plus concentration. And remember, do not forget to put this 2. Whatever is the coefficient, that has to be given in the power. Okay. Okay. Next, we'll move to Faraday's law. Okay. Now in Faraday's law, we have Faraday's first law and Faraday's second law. Okay. So, okay. Now Faraday's first law, Dhruva Kolkar is asking previous question. So just a minute. Let's go back to the previous question. Okay. I think Dhruva, you are asking this question. I have calculated the molarity of this given concentration, right? It is 0.06%, means 0.06 gram, that is the given mass. Urea is there, so urea molar mass is 60 into 1000 divided by the volume. Percentage means volume will be 100. So if I calculate, I get the molarity as 0.01. So I have to find that option where the molarity will be 0.01, and that will happen only, it is directly given here in option number D. So that is why option number D here. Okay. Yes, Ajay, this video will be sufficient to get good marks in your. Okay. Next, in your KCET exam, Faraday's law, we have two Faraday's law, Faraday's first law and Faraday's second law. Before that, I want to tell you two more formulas. See, delta G is equal to minus NF into E naught of the cell. How to calculate E naught of the cell? E naught of cathode minus E naught of anode. Okay, and then we have E naught of the cell equal to 0.059 N 0.0591 by N log of K. Okay, so this will be the formula. Clear? Okay. Okay. Next, we will move to the next one, that is, answer is B. Why the answer will be B? Let me just check. here I got 0.01 molarity, right? Knowledge games, you can check here. I just cancel this one. I have 0.6 by 60, so I can cancel 0.1 by 10, and I got 0.01, right? So which option is having 0.01 m's, the same concentration that is present in option number D, so that is why it will be D. Okay. Students, which question you are asking? Tell me this question, is it clear to everyone? Okay, I am once again explaining this question. All of you see, those who are having doubt. Isotonic solution means the osmotic pressure should be equal. Okay, and what is the formula for osmotic pressure? Is equal to C into R into T, right? C here stands for molarity. So first let me calculate the molarity of the given solution. What is the molarity formula? Given mass. Okay, what is the formula for molarity? Molarity is equal to given mass by molar mass into 1000, okay, by volume of the solution. What is the given mass here? 0.06, right? What is the molar mass? Urea molar mass is 60 into 1000. What is the volume of the solution? 100. Why? Because it is given percentage W by V. That means volume will be 100. So if I just calculate this one, it will become 0.01. So the molarity is 0.01. Now which option is having 0.01 molarity? That will be isotonic. And if you see here, it is given 0.01 m. So that is why option number D here. Here it is 0.06. Please all of you see here, I cancel this one. Here it is 0.06. You cancel this one, you cancel this one, and then you are left with 6.01 molarity. I hope this is clear. Please students, just put a thumbs up if it is clear now. Chetna, please see the calculation once again. You have 0.06 divided by 60 into 1000 by 100. We cancel 20, 20, 10, 10. 0.06 divided by 6, it is 0.01 molarity. Okay. Those who are clear with this, please put the thumbs up now. Is this question is clear to everyone? Please put a thumbs up quickly. Okay. Okay, now let's move to what I was discussing. Yes, Faraday's. So these are the formulas that I want to discuss. Delta G is equal to minus NF E naught of the cell. E naught of the cell will be equal to E naught of cathode minus E naught of anode. E naught of the cell equal to 0.0591 by N divided into log K, where K is your equilibrium constant. Okay. Next, we have Faraday's. For first law, statement is not required. You should be more worried about this formula, where Faraday's mass deposited is equal to Z into I into T. Z is what? Equivalent, electrochemical equivalent. Its formula is molar mass divided by N into 96500. Okay, then I is the current and T is time, and this time should always be in seconds. So if the question is given in some other units, you must convert it into seconds. Okay. Okay. Next, we will have Faraday's second law, where we have m1 by m2 equal to equivalent weight of 1 divided by equivalent weight of 2. So this formula when you have to use if you have two cells. Okay, here also there is cell, here also there is cell, and some mass is deposited on this cathode and some mass is deposited on this cathode, and you have been given both the cells equal amount of current. So then what is the mass deposited on this cathode? m1 divided by m2 will be equal to equivalent weight of 1 by equivalent weight of 2. Now how to calculate equivalent weight? Equivalent weight is equal to molar mass, okay, divided by n factor. Molar mass divided by n factor. What is this n factor? N factor is number of electrons involved. Okay, number of electrons involved in this one. Okay. Next, We will go for products of electrolysis. Here I will be telling you which one you should remember, the most important one, molten NaCl and aqueous NaCl. Okay, you just have to remember that in molten NaCl at cathode sodium metal will be produced, and in aqueous NaCl hydrogen gas will be produced, and in both the cases Cl2 gases will be produced. Okay, so anode reaction will be what? Chlorine reaction, and what will be the cathode reaction you should be knowing. So majorly you need to know the products. Okay. Next, if I go to dilute H2SO4 and concentrated H2SO4, in dilute you will have O2 and H2, and in concentrated you will have H2O8 and H2 gas. Okay, so that you should be knowing. Clear? Next, we will go to conductance of electrolyte. This is very, very important. An electrolyte solution is there. Okay, what are the terms we should be knowing? We have resistance, resistivity, conductance, conductivity, cell constant, and molar conductance. Okay, these are the terms. These are the units. So definition you don't have to remember at this point of time. You should know the units. So what is the unit of resistance? Ohm. Unit of resistivity, ohm meter or ohm centimeter. Then conductance is opposite of resistance, we called it ohm inverse or Siemens. Then conductivity, this is conductance, this is conductivity, S centimeter inverse or S meter inverse. Then we have G star, that is your cell constant, that is meter inverse or centimeter inverse. Then lambda m, molar conductivity unit is S centimeter square mole inverse or S centimeter square or S meter square mole inverse. Okay, now I will show you all the formulas for this one. Yes, all of you please note down all these formulas quickly. Okay. Yes. Matrix, ma'am, will you complete the whole syllabus? Matrix, I will be covering today physical chemistry and inorganic chemistry, most important concepts, questions. Okay, then tomorrow we will be doing organic chemistry. Physical and inorganic I will be doing today. Okay, so you can see resistance formula is what? R is equal to rho into L by A. Rho is resistivity, L is the length, A is the area. Resistivity is this one, rho. So just opposite of this one I will take. So I will get R into A by L. Then cell constant is L by A. Then you have conductance. Conductance is the opposite of resistance. 1 by R I can write down, or I can write out in this form, that is A divided by rho into L. Right? Just I have to reverse this one. So A divided by rho into L. Conductivity is the opposite of resistivity. So you will get ARL divided by A into R. And then lastly we have molar conductivity. Molar conductivity formula is equal to kappa into 1000 by C. Okay. Okay. Next, let's discuss about the variation of conductivity. So here students, please listen, this is important, that if you decrease the concentration, okay, if concentration will decrease, then what will happen? Kappa value will decrease, but molar conductivity value will increase. So this is an important concept that you should remember. When we decrease the concentration, kappa value decreases, but molar conductivity increases. Okay. Okay. Next, we will see the molar conductivity will increase for both strong electrolyte and weak electrolyte. Okay. So, but what is the reason for that? See, when you decrease the concentration, okay, the mobility of the strong electrolyte will be more, means the ions that were present, you will be having one plus and one minus, right, cation and anion, they will be very close to each other. But when you dilute it, these plus minus ions will separate and can move farther from each other and can move easily far away from each other, and their mobility will increase and they can conduct electricity very well. But if they are weak electrolyte, in that case what happens? The dissociation increases, okay, the rate of dissociation increases. Weak electrolytes have partial dissociation, but when you dilute it, their dissociation will increase. So this is the graph for strong electrolyte, the increase is slight, but in case of weak electrolyte you can see a very strong increase in the molar conductivity. Now here one very important equation, this graph that we are doing here is coming from this particular equation, which is called as d by Huckel-Onsager equation, okay, where lambda m is equal to lambda naught m minus a into root over of c. Now a is a constant or slope of the graph. Now A is same for same type of electrolytes. This is a question that was asked in the previous year. We will discuss same type of electrolytes. Means in an electrolyte what we have? Cation and anion. If I have electrolyte 1, electrolyte 2, cation 1, cation 2, anion 1, anion 2. If the charge of cation 1 and the charge of cation 2 are same, and the charge of anion 1 and the charge of anion 2 are same, then we call them as same type of electrolytes. Okay, all of you are getting? Okay. Okay, let's move to Kohlrausch law here. Okay, next Kohlrausch law tells you what? Limiting molar conductivity. You can see in this equation, if you see the previous equation, you can see lambda naught m, right? There's a naught symbol there. That naught symbol gives you the molar conductivity. Okay, it tells you about the limiting molar conductivity. What does that mean? That when the concentration is very dilute, okay, when you have decreased the concentration, the conductivity will increase, the molar conductivity will increase. The maximum value of molar conductivity that can be reached is called as your limiting molar conductivity. Now Kohlrausch law is used for what? To calculate the molar conductivity of the weak electrolytes. For example, if I have a electrolyte like this, okay, then the molar conductivity of this one will be this one plus Cl minus. Okay, if I have like this something MgCl2, then that will be equal to lambda naught of Mg2 plus 2 times lambda naught of Cl minus. Okay, clear? Okay, next. Okay, voice, other students please confirm if the voice is audible or not. Okay, fine. Let's move to, there's a formula for calculating alpha. What is alpha here? Alpha is the degree of dissociation. Okay, so and how to calculate alpha? It is lambda m by lambda naught m. Lambda m by lambda naught m, where lambda m is the molar conductivity and lambda naught m is the limiting molar conductivity. Okay, clear? Okay. Next, batteries. We have two types of batteries, right? Primary batteries which we cannot use again and again, and we have secondary batteries which we can use again and again. Examples you should be knowing. What are the examples of primary batteries? Dry cell and mercury cell. And what is the example of secondary batteries? We have lead storage battery and nickel cadmium cell. Next, in dry cell you should be knowing what is anode, what is cathode. Like this questions can be asked, like what is the cathodic reaction in dry cell. So you should be knowing MnO2 plus NH4 plus, and what is the anodic reaction here. Similarly, mercury cell, zinc is the anode but HgO is the cathode. So you just need to know which is anode, which is cathode. Exact reaction you don't have to remember, but yes, what is there at least that you should be knowing. Okay. Okay. Next we will go to lead storage cell. Okay, this is very important. Lead storage battery is very important. You need to know the entire equation here. This is a previous year question, has been asked from here. So please see what is happening in lead reaction. Generally in lead reaction what happens? Lead gets oxidized, Pb0 to Pb plus 2. It is getting oxidized, 0 to plus 2, and here Pb plus 4 is getting reduced to plus 2. Okay, so that which one is getting oxidized and which one is getting reduced, that you should be knowing. And this is your anode reaction, this is your cathode reaction, that you have to remember. Okay. Okay. Students, am I audible? Just let me adjust the mic. Let me know if I am audible to all of you. Am I audible, students? Everyone, please confirm. Yes, if I am audible, please do confirm and let me know. Okay. Okay. Fine. Next, we will go for fuel cell. In fuel cell also you just have to remember what all things. See, I am telling you what all things you have to revise at this point of time. Okay. In fuel cell you have to know that it was used in Apollo space program. That's the first thing you should be knowing. Then on the anode you have hydrogen and on the cathode you have oxygen, and then you have an electrolyte. What is used as electrolyte? Aqueous NaOH is used as electrolyte. That is the third thing that you should be knowing. Next we have what is catalyst here, finely divided platinum or palladium metal. Okay, this is asked as a previous year question, so please remember these 4 points about the hydrogen oxygen fuel cell. Hydrogen is anode, cathode is oxygen, electrolyte is aqueous NaOH, and this was used in Apollo space program, and catalyst is finely divided platinum or palladium. Okay, okay. Next, this is the reaction, so you should be knowing what is the cathode reaction, what is the anode reaction, and what is the overall reaction. Note students, please don't worry, you will be getting it in our WhatsApp channel, so please join the WhatsApp channel. Our link will be there in the description section. Okay, okay children, let's move forward. Corrosion also we will see. Corrosion reaction is also important. In oxidation, what is happening? Fe is getting converted to Fe2 plus, and in reduction O2 is getting converted to 4H plus 4 electrons to give you 2H2O. Okay. Next we have the overall reaction here, so please yes, Red Wing or Apollo can also be asked here. Okay, okay. Next we have this overall reaction, that also you should be remembering. Okay, fine. Now let's solve this question. All of you please try this question. This is from Nernst equation. Yes students, anything can come. Okay, last year questions have been coming like this, so please prepare properly, and now everyone solve this question with me. Please solve this question and give me the answer. Yes. Okay, I'll be taking all your questions little bit now, and others please solve the question. Please don't get distracted. I can see so many chats here, but I don't want all of you to get distracted. Please solve the questions. Karthik Gadgets, this is a revision video. Okay, I'll be only telling you what all important things are there. If I go in detail, that will not be helpful at this point of time, and we cannot cover all the topics as well. Okay, so whatever is important for the exam point of view, what you have to focus, that all things I am explaining. Okay. Okay. Dhruv, in that case you must solve the questions. Okay, you can but you can, for example, work done in an expansion process is there, and you know that answer will be negative in that case. For example, delta G value is there, you know that negative answer will be there. So in that cases you can eliminate the positive options and you can calculate for the negative, correct negative option. Okay, yes. Okay, now let me solve this question for all of you. What is this? This is Nernst equation. You have to calculate the pH of the solution. Okay, so now if I want to solve, it is a little bit lengthy question. Okay, so how we can solve it? First of all, I will write the Nernst equation. E of the cell equal to E naught of the cell minus 0.059 divided by N log of, okay, product concentration divided by reactant concentration. So Cr3 plus, okay, square divided by this side I have Cr2O7 2 minus, and then I have H plus, and their power will be 14, right, because I have 14 H plus. So let me now put the values here. What is the value of E of the cell? 1.067. What is the value of E naught? 1.33 minus 0.06. N value, I am taking this one rounding off to 6 so that I can cancel it easily, right? Next, Cr3 plus concentration is 15 millimole, so 15 into 15, log is there definitely, and Cr2O7 is 4.5, okay, and you have H plus is I have to calculate the H plus concentration to the power of 14. Okay, now what I can do? 15.3s are 3 1s are 3 5s are, and if I'll get log 50, right? So I can write down this as 1.067 equal to 1.33 minus 0.01, and I have log of 50 divided by H plus to the power of 14. Okay, now I can just calculate this one, right? 1.33 minus 1.067, okay, Next 10 minus 7 3, I have 12 minus 6 6, and then I have 2, right? I'll get 0.263. Okay, so I can just write down this one minus 0.263 divided by 0.01 is equal to minus log of 50 by h plus to the power of 14. Okay, now what I can do, if I just solve this, I'll get minus minus I can cancel, and this I can write like this. You can get 263 divided by 100, and I have 1 by divided by 1000, right? So I will get here 26.3. Okay, so I will have 26.3 this side. So let me just solve on this side. All of you can check this side if I am just obstructing that one. So that is 20, oh sorry, 1 second. Yes, so if I have 26.3 equal to log 50, how will you calculate log 50? Now see, log 50 can be written as log 5 into 10. Okay, now log 5 is 0.6, right? And you have 10, log 10 is 1. Log a into b is log a plus log b. So I can write it like this, log 5 plus log of 10, right? Now can we just do this? Just a minute. Okay, so I can write it as this one. I can write it as log of 0.698 plus 1, that is 1.698. So I will write it here as this part. I can write it as log 50 is 1.698. Okay, minus, so just let me erase this one. Okay, log of 1.698 minus log of h plus to the power of minus 14. Okay, so next what again we can solve this, we can just do this calculation here. This one will come like this, 26.3. okay, 26.3, then I have 1.698. okay, so 10 minus 8 2, 9 minus 9 is 12, 6, I will get 24.602. okay, that is equal to, I will have minus of 14 log h plus. Okay, now this 14 I can divide on this side. Now if I divide this 14, 14 2s are 28, so it will be 1 point something, and or you can be saying near to 2, so that is why option number A here. Okay, clear? Any doubt in this question? Pradeep, time will be sufficient dear, definitely, because you will be getting certain questions which can be solved within 1 to 2 seconds also, so you will get time, please don't worry. Okay, so next we have this question. Can you all try this question quickly? All of you please try this question. Chandrasekhar, you will get definitely dear organic and inorganic, and you will be able to solve these organic questions in 5 to 10 15 seconds. Just there's no calculation there, so you have to give some time for physical chemistry. You will manage, it will be, if you write mock test from now onwards, you will be able to manage time. So please don't worry everyone, you will be able to manage the time. Okay, Spurti, n value was already given in the question 6. Just a minute students, you can see 6 electrons are there, right? So that is why I took n as 6. Okay, okay, let's move for this question. All of you please solve and tell me how much we will get. Yes, yes students, how can I get this one? So I can see so many heart shapes coming here. Okay, so students, I hope you are enjoying the session. I am with you, please don't worry. We are going to cover each and every important concept, and we will do proper revision, and we'll go for the exam with full confidence. I know my children will do very, very good in exam, right? Let's solve this question. Yes, A. I have got so many answers with A. Okay, C and D, they get eliminated. Okay, yes, definitely. Actually, you can eliminate D because that is not a similar option. You should to focus on the similar option. So I need to calculate how much magnesium got deposited, right? So we have this formula, M is equal to Z. For Z, it is equal to molar mass divided by N into 96500 into I into T, right? So what is M here? M is the what we have, the mass I have to calculate. What is the molar mass here? 24 for 2 divided by 96500. Current is how much? 1 ampere. And if you see this one, 16 minutes 5 seconds, it is 965. It is given like this so that we can easily cancel this one, right? So I will have 12, right? So that will give me 0.12 mass. Okay, this is the mass, but we have to calculate the molarity. So to calculate molarity, what I have to do? Given mass again, 0.12 divided by molar mass into, you have 1 liter of the solution. So you just have to solve this. So I can write down as 1 by 2 or 0.5 into 10 to the power of minus 2, or I can write 5 into 10 to the power of minus 3. All of you have done very well. Okay, next we'll move to this question. Can we solve this question without using pen and paper? I want all of you to solve this question without using pen and paper. Okay. Yes, Vicky, tomorrow another live class on organic chemistry. Okay, today physical and inorganic, tomorrow we will do organic. Okay. Chandrasekhar, it is definitely very good marks, but you can improve, right? You still have the scope to improve. You can target 130, 135 plus also. How N is 2? Okay. So, dear C, magnesium, what is the charge here? Mg is Mg2 plus, right? So, Mg2 plus will gain 2 electrons to get converted to Mg. So, that is why N equal to 2. I hope all of you are getting. Okay. Next question. You have MnO4 minus 2 MnO2. MnO4 minus 2 MnO2. So if I am converting this one MnO4 minus 2 MnO2, how much Faraday of electricity will be required? That is the question. Now what is the oxidation state of manganese here? I can have X minus 8 equal to minus 1, X is equal to plus 7, right? And here it is plus 4. So plus 7 to plus 4, how much Faraday of electricity is required? How much gain of electrons should be there? 3 electrons, or I can say 3 Faraday. So that is why option number B here. Okay. Those who are getting D, it is wrong, dear. It is option number B. Okay. Clear? Next. Okay. Let's move to the next question. Equilibrium constant you have to find out. Okay. So please try this question. You have the E of the cell is given. So what is the formula? E of the cell equal to 0.059 by N log of K. Okay. So can we solve this question? We have E naught of the cell is 0.22. 0.22, and this one I'll write it as 0.06 for easy calculation. Now can I see the number of electrons that is used? So H2 to H plus there is 2 electrons, and 2 Ag plus to 2 Ag there is 2 electrons. So this is definitely 2 log of K. Okay. So next we have 0.03. So if I just divide this once, it will come 3 sevens are 21. 7 point something will come. That is equal to log of K, right? 7 point, for example, X. 7 point X has come. Now what I can do? I will write K equal to 10 to the power of 7 point X. That is equal to 10 to the power of 7 into 10 to the power of point X. Now I don't have to worry about this, because if you see the values, I have 10 to the power of 7, only one option, and that is why option number A will be the correct answer. Okay. Yes, very good Ujay, very good Sharu. All of you are getting A, that is correct. Okay. Shagufta, happy to see you again. Yes. Next question, can we quickly solve? I want all of you to do it quickly. Quickly solve it. Yes. Yes, Chandrasekhar, we are going to do the chapters of PU1 as well in chemistry. So let us just quickly finish this off. We will be going for that. B is coming. Okay, just a minute. Let me check once again. So how much I will get? 22 divided by 7. So 3.14, right? Okay, just a minute. Let me just check. Uh, 22, okay, sorry, I should do 22 by 3. I got 22 by 3. So those are saying it is B. Just let me wait, students. Just let me check it. So I will get you will get 2 into 2. This is only correct, students. Option number A is correct. Okay, I have checked with calculator also. You will get option number A. Okay, yes. Now this question, option number C, those who are getting option number C, those who are saying that is correct for this question. You have NaClO3 and you have NaClO4, right? What is the oxidation charge here? NaClO3 to NaClO4. Okay, so I have here +5 oxidation state and here I have +7. So I can say that I will require 2 moles of electrons. Now what is the question here? How many moles of NaCl4 will be formed when 3 Faradays of electricity is passed through NaClO3? Now see, if I give 2 Faradays of electricity to NaClO3, I am getting 1 mole of NaClO4. If I give 1 Faraday, then I will get 1 by 2 moles of NaClO4. Right? In the question it is given that 3 Faraday is given. So that will be 1.5 moles. So option number C here. Okay. Okay. Yes. Okay, next we'll go to kinetics now. Okay, so I think kinetics is a very easy and a favorite chapter of many of you. I think that is a easy question, easy chapter. So I'm not going that much in detail. So just let me just quickly cover up the concepts. The unit of rate constant for any nth order reaction will be moles to the power of 1 minus n, liter to the power of n minus 1 and second inverse. Okay, moles to the power of 1 minus n, liter to the power of n minus 1, second inverse. Next, what I have? Order. What is the definition of order? The sum of the powers of the reactants in the rate law expression. That x plus y is the order of the reaction, and order of the reaction is calculated experimentally. Okay, by seeing the reaction we cannot. Very good, Aditya. Very good. That you are getting correct answers. Okay, order of the reaction will be x plus y, and order of a reaction can be 0, 1, 2, 3, anything. Okay. Next, molecularity is what? Molecularity will be the number of reacting species in a particular reaction. Okay, so for example, if you have a reaction like this, here number of reacting species is 1, here number of reacting species is 2, here the number of reacting species is 3. So that is the molecularity of a reaction, right? So okay, just a minute. Yes. Next we will see what is the integrated rate equation. So you know, for 0th order what is the integrated rate equation you should be knowing, and for first order reaction what is the integrated rate equation, that we will be knowing. Okay. So 0th order equation, rate is equal to K, then you have integrated rate law, KT equal to A naught minus A, and unit of K is equal to mole liter inverse second inverse. I think all of you know this formula, so I'm just revising quickly. And then for 0th order, first order reaction, you should be knowing the formulas here. So one second, just a minute. Okay. Okay, so let me just write down the first order formulas here. What we have? KT equal to 2.303 into log of A naught by A. Okay, that is the equation for your first order reaction. And what is the half-life formula for first order? 0.693 by K. And one another important relationship you should know is T 99.9% is equal to 10 times of T 50%. Okay, this is what you should be knowing. Clear? Okay, next. Okay, next we'll come to first order reaction graphs. You can see if you have graph for ln R versus T, the slope will be a negative slope, and if you have log R naught by R versus T, you will have a positive slope. Okay, so please just draw this graph and remember this graph, that can be useful for you. Okay. Next, examples of first order reaction. You should know this is an important example, decomposition of N2O5 and N2O. This is an example of first order reaction. Questions was asked from here in the previous year, so please pay attention in this example. You have natural and radioactive decays are your first order reaction. Hydrogenation of ethene is a first order reaction. Next, half-life, if I see, what is the formula? T half is equal to A to the power of n minus 1, and for 0th order the half-life formula is A naught by 2K, and for first order the half-life formula already I told you 0.693 by K. Okay, Wiki biology class live will be told to you, it will be notified in the channel if there is any live class for bio. Okay, I hope your answer is clear, so please don't spam now. Okay, just a minute. Pseudo first order reactions, please, you can see here what is pseudo first order reaction. The reactions that appear to be first order, but it is actually, that appears to be some other order, but actually it is a first order reaction. Okay, that pseudo first order reaction happens when you have like one solvent in excess. Okay, okay. Then we have here effect of temperature. Okay, so in effect of temperature, for every 10 degree rise, the rate constant actually nearly gets doubled. Okay, so girl, ma'am, is this enough to score 35 plus? Yes dear, it is enough. If you prepare properly, if you do these questions and practice these formulas, it will be enough. Okay, okay. Next we have Arrhenius equation, K equal to A into e to the power of minus EA by RT. Okay, that is there. Then we have here the graph, activation energy, enthalpy of the reaction and activated complex energy. That diagram is important. Next we have this one, this graph. If I just take the logarithm or ln of the Arrhenius equation, I will get ln K is equal to ln A minus EA by RT. So that will be giving you this graph. And if I have this log K2 by K1 is equal to EA by 2.303 R 1 by T1 minus 1 by T2. So these are the important formulas of kinetics, and I hope this chapter is easy for you. So I'll be quickly solving some questions. So please solve this question. For a reaction, A plus 2B gives you products when the concentration of B is increased. Okay, B is increased, half-life remains the same. So remember, if the half-life is not depending on concentration, then that is a first order reaction. Okay, so half-life remains the same, that means half-life is not affected by the concentration. That means suppose for this reaction I am writing R is equal to K into A to the power of X and B to the power of Y. Okay, so now if the concentration of A alone is doubled, sorry, if the concentration of B is increased, the half-life remains same. So that means this Y will be equal to 1. Okay, so please remember, don't put it 0, it is given about half-life. So if you are increasing the concentration of B, the half-life remains the same. That means with respect to B, the order is 1. Now if the concentration of A alone is double, the rate remains the same. Means if I change the concentration of A, okay, rate is same. That means what? This value is 0. That this value is 0 because it is not affecting the rate order, it is not affecting the rate of the reaction. So what I can have, R is equal to K into A to the power of 0 and B to the power of Y value is how much? 1. So this is which order reaction? First order reaction. 1 plus 0 is 1, first order reaction. So what is the unit of first order reaction? S inverse. Okay, yes. Okay, those are saying A, that is absolutely correct. Next, can we solve this question? This is a previous year question. Let's move to the next question, students. Can we solve this question? Yes. Please solve this question and tell me. Yes. Can we answer this question, student? Everyone, please put down the comments quickly. I'm waiting. I am not able to see all of your comments. Just a minute. Okay, fine. Arpita, P block is not there, salt analysis is there. Here students are saying B. Okay. Okay, let's solve this question. Okay, let us solve this question. All of you know differential equation. Okay, all of you know differential equation, how to write. Rate is equal to, okay, rate is equal to 1 by T, 1 by 2 dA by dt, okay, equal to 1 by minus dB by dt, okay, equal to 1 by 3 dC by dt. Okay, now here what I can put for dA by dt, can I put this value K1A square? So minus 1 by 2 K1A square is equal to dB by dt is equal to K2A square, and here I have 1 by 3 into K3A square. Right? Are you getting this much? Can I cancel A square from all of them? Yes, ma'am, I can do that. Now what I can see, you can see how can I see the option. Here I have K1 by 2 is equal to K2 equal to K3 by 3. I have here K1 by 2 equal to K2 equal to K3 by 3. Do not worry about the signs, because this sign only tells you whether it is a reactant or a product. It doesn't have anything with the value. So I will get K1 by 2 equal to K2 equal to K3 by 3. Yes, my students are getting option number D. I am very happy with that. Yes, all of you are correct here. Those who are saying D, correct answer will be option number D here. This is a very good question. Similar questions can be expected. Yes, so happy to see you. Okay, Arpita, definitely your request is my command. We will be definitely bringing you salt analysis. What type of questions can be asked, I will be adding up. Okay, do not worry. Okay, so who was this? Arpita, I hope that is clear. Okay, let's move, students. I can find that all of you are getting little tired. Don't get tired till the exams. Okay, I am working hard. Do work hard with me. Let's do the next question. Let's get started with the next question. You have to tell the overall order of the reaction by RDS method. RDS is not any bomb here. What is RDS? RDS is rate determining step method. Yes. Here tomorrow we will be having class again at maybe at 5 p.m. again tomorrow we will do, okay, but I will confirm again. Okay, we will please be just aware, just be put your notifications on. We can have a class tomorrow, but timings will let you know in the comment section in our channel. You will be knowing. Okay. Okay, voice is low. Students, I am getting tired, I think, with. I hope the voice is clear now. I have just adjusted the mic. PDF will be available in WhatsApp session. In our WhatsApp channel, all the PDFs will be downloaded. So please don't worry about PDF now. Solve this question and tell me the answer. I don't want any other conversations. Yes, only the answers I want. Yes, students, C. I am getting C as the answer. Many of you are answering C. Let's see here. RDS method. Okay, according to RDS method, what does it say? That the rate determining step is the one which tells you the rate of the reaction. Okay, so according to this one, rate I can have by RDS method. This is the slowest step, K into A into B2. Right, let me put here it is 1 and here it is 1, so it is like this. But if I see the overall reaction, is there any term A there? No, right? A is not mentioned. That means I cannot take A directly in the equation. I have one more equation where there is an equilibrium. So can I write for the first equilibrium, K equilibrium is equal to A square, that is product concentration A into A divided by A2, right? So that will give me what? K equilibrium into A2 is equal to A square, right? Now if I take root over of that one, K equilibrium into A2, right? So that will give me, just a minute, I have to put this 2 here, okay, 1 by 2. So what is the value of A here? A value is root over of K equilibrium into root over of A2. Now I can substitute that here, K into, what is the concentration of A? K equilibrium root over into A2 root over into B2. Okay, so now you can see this is all constant. We have B power is 1, B2 power is 1, A2 power is 1 by 2. So 1 plus 1 by 2, it is 3 by 2. So option number C is the correct answer. Yes, those who are giving this answer number C, it is absolutely correct answer. Okay, next, can we do this question? Students, can we try this question? Next question, all of you, can we try? Yes, Kirtana, this will be available in recorded form, don't worry. Yes, can we have this question now quickly solved, everyone? Yes. Yes, Kirtana, recorded video will be there. Next question, all of you, please solve. You have a reaction A2 plus B2, okay, gives you 2AB. Okay, now what is happening? The energy of activation for the forward and reverse reaction are 180 and 200 kilojoule per mole respectively. Okay, so we have here A2 plus B2, okay, and then we have forward reaction and backward reaction. Okay, so for forward reaction it is 180 and for forward reaction it is 180 and for backward reaction, so I have to draw like this. So let me just draw this graph little bit more in a better way. Okay, so you can see the reaction like this. Okay, so this is A2 plus B2, okay, and this is AB. Now we have that for the forward reaction, the energy, activation energy is this one 180, okay, and for the backward reaction it is 200, right, 180 and 200. Now what happens when you add the catalyst, both of them reduce by 100. So there is a, if I add catalyst, suppose this is there and this value is now 100, okay, the activation energy decreased by 100 kilojoule per mole. The enthalpy change of the reaction, for the reaction you have to calculate. The enthalpy change means you have to tell this value. What is this value? Can we say what is this value? Yes, anyone? Have you answered? Believer, we will be doing for another half an hour to 45 minutes. Okay. Okay. Yes, can we have this one? How much we will get? Can you think? See, enthalpy of the reaction has nothing to do with the catalyst. Catalyst can change, but enthalpy of reaction is not affected by that. Earlier this was 180, right? Now this was 200 and this is 180. What is this difference? Total was 200 and this is 180. What will be this difference? It will be 20, right? So option number A. When you use catalyst, enthalpy of reaction is not affected. So this line, the presence of catalyst lowers the activation energy by this much, is completely irrelevant for this question. It doesn't have any effect in that. So I have to do the simply, you have the, suppose just imagine this catalyst is not there. Just imagine like this. We don't have this catalyst, right? So this one total energy is 180, this total energy was 200. So what is this energy? 200, or 180 minus 200, that is minus 20. Yes, Vaishnavi, absolutely correct. Okay. Next, we'll go to thermodynamics PU1 topic. Okay, so let us quickly, I will explain all the formulas that you have to remember. See, for thermodynamics, no need to go too deep into concepts. You can just revise the formulas and do previous year questions. That is more than enough. Okay, so what is W formula here? W equal to, first we have P external into V2 minus V1. If you are having notes, please write down the formula with me. Minus P, then W in case of isothermal and reversible process, that is equal to minus 2.303 nRT log of V2 by V1, or we can have minus 2.303 nRT log of P1 by P2. Okay, next, what is first law here? Delta U is equal to Q plus W. Okay, next you should remember, for isothermal process, this is important, for isothermal process delta U is equal to 0. Okay, and at vacuum P external is equal to 0, so work done will also be 0. Clear? Now sign convention, see, if Q stands for heat, okay, Q stands for heat. If heat is added, then we will have positive sign. If Q is removed, then we will have negative sign. Similarly, if work is done on the system, then it will be positive, and work is done by the system, okay, then it will be negative. Clear? These are the sign conventions. Okay. Okay, Chandu. Hello, Chandu. Good evening, and I hope you are doing well. Next, coming to Hess's law. See, Hess's law means what? You have suppose 3-4 reactions. Okay, you can arrange those 3-4 reactions to get a final equation. Means suppose I have A plus B is giving me C, C gives me D. Enthalpy of this reaction is 1 and enthalpy of this reaction is 2. Now I have suppose a final reaction which is A plus B gives me D. Right? If I just add these two reactions, now the enthalpy of this reaction will be first reaction enthalpy plus second reaction enthalpy. Okay. How to calculate enthalpy of a reaction? Enthalpy of a reaction is equal to total enthalpy of products minus total enthalpy of formation of reactants. Okay, enthalpy of products minus enthalpy of reactants. Next, what else I have? Enthalpy of the reaction is equal to bond enthalpy of reactants minus bond enthalpy of products. Okay, bond enthalpy of reactants minus bond enthalpy of products. Next, delta H is equal to delta U plus delta NG/RT. Okay, this is another formula where delta Ng is what? Number of gaseous moles of products minus number of gaseous moles of reactants. Okay. Arpita, I have a specific session on practical questions. Please just go and search practical questions KCET. You will be getting that in my channel. You can watch that video. Okay, in this channel, Deeksha Karnataka, you will get. Okay. Believer, this will be helpful. I'm just discussing the concepts. If you go and revise these concepts, do questions from this concept, this will be definitely be helpful. Okay. Yes. Okay. Next, we will be talking about spontaneity. What are the criteria for spontaneity? Delta G should be negative and delta S should be positive. Okay. And what is the equation? We have delta G is equal to delta H minus T delta S. Okay. This is the equation. Clear? Please note down this formula. Okay. Now let us solve this question. The work done when 2 moles of an ideal gas expands reversibly and isothermally from a volume of 1 liter to 10 liter at 300 Kelvin. So you can see such direct formula based questions will be asked from thermodynamics. So please do not worry about PU1. Just revise these much topics that I have given you. This chapter is done for you. Trust me. Okay. So now can we do this question? What I have, minus 2.303 into n value. N is how much? 2 R is 8.314, temperature is 300, okay, log of V2 by V1, 10 by 1, right, log 10 by 1. So now always remember here a shortcut, 2.303 into 8.314, okay, this value is 19.1. If you remember this value, you can save a lot of time, right? So this is 19.1, okay, into 2 into 300. So I can have like 3 2s are 6, so 6 1s are 6, 6 9s are 54, 5 6 1s are 6 plus 5 11, and I have this 2 zeros, okay, and then I can put a decimal here, so I will get 11.46 kilojoule minus, okay. So that you can see option number C will be the correct answer, okay. Yes, Shilpa, you can definitely get 40 plus if you do these questions, okay. Now this question is from your Hess's law. I told you how to do the Hess's law question. So you have been given with 3 equation, NH3 plus 3Cl2, N2 plus 3H2, H2 plus Cl2. 3 equations are given, okay. The heat of formation of NCl3 means you want to form NCl3. So what will be the equation for that? So what you have to do, first of all, you have to write the equation for heat of formation of NCl3. You have to write the equation for heat of or for the formation of NCl3, and you have to arrange these given 3 equations in such a way that you get the formation enthalpy of NCl3, okay. So just a minute. Okay, so now if I see, okay, now let's see, I want to write the I want to form NCl3, okay. This question all of you please check. If you want to form NCl3, the elements should be in their native state. So what is the native state of nitrogen? N2, right? I need only 1 nitrogen, so half N2 plus Cl3. Cl2 is the native state, but I need 3 by 2 Cl2, okay. Now you have to use these equation. In which equation I have N2? You can see in the first equation. In the second equation I have N2. So I will multiply half to the second equation. So what I will get? See, half N2 plus 3 by 2 H2, okay. Then I am multiplying half to this one, that will give me NH3, okay. Now if I multiplied here, then here also I have to multiply half, so minus 1 by 2 H2. Okay, I am not writing delta, just like this. Next I need 3 by 2 Cl2. So I have Cl2 in this equation. So just let me multiply Cl2 to this equation, okay, third equation. So what I will get? 3 by 2, if I multiply there, I will get 3 by 2 H2, just a minute. Yes, so let me write down 3 by 2 H2, okay. For the third equation I am multiplying 3 by 2. 3 by 2 Cl2, okay, that gives me 3 by 2 means 2 will get cancelled, 3 HCl, okay. Now you see I have got my N2 and I have got Cl2. I need NCl3, which is in this equation, right? So I can add this equation, the first equation I will add, and here what will be the value? 3 by 2 of H3. Now third equation I am adding, that is NH3 plus 3Cl2, that gives me how much? NCl3 plus 3HCl, okay. So the heat of formation of NCl3, I think we have done it, okay. Yes, now you have to just solve this equation. Can you just solve this, add these equations, and then finally we will be ending up on this equation, right? Any doubt? Please solve this and tell me now what we will get. A and C same option. Let me check. Yes, A and C both are same option. By mistake maybe there be some problem, okay. Yes, so what we will get here, just you have to solve this. Now you can see NH3 will get cancelled, all other terms will get cancelled, and then you can get the answer as option number A or option number C. You just have to add this and check the value, okay. Are you getting all B? Okay, sorry. Okay. Yes. You have to write, students, you have to just add these equations, okay, and then you have to find the final equation where I will be getting this particular compound. This is my required equation, okay, and I have 3 other equations. NH3 and NH3 got cancelled. I have NCl, okay. Okay, there is a 3 HCl is pending here, right? Okay, 3 HCl is there. Okay, just a minute. Okay, I think we can reverse this second equation. Okay, if I just reverse this second equation. Okay, so students, what I have to do is I have to reverse the second equation so that all other things can get cancelled. Okay, so just let me reverse the second equation. Just give me 1 minute. Please reverse this equation, that is which one we took, this equation. Okay, what we got, we can just reverse. We multiplied 3 by 2, right? So I will write 3 by 2 H2 this side and 3 by 2 Cl2. Okay, and this side I will have 3 HCl. Okay, so I can cancel this 3 by 2, this 3 by 2, 3 HCl will get cancelled, and I have half N2 plus Cl2 gives me NCl3. Okay, works. You can see this 3 by 2 and this 3 by 2 that we will get. So I have to just reverse this equation. Okay, so I will be getting, I hope this is clear. Okay, fine. Just please reverse this equation and then add, you will get the answer, students. Let's move to the next question now. Now this is important question, for which reaction delta H will be greater than delta U. So you have delta H is equal to delta U plus delta Ng RT. Okay, I want delta H to be greater than delta U. So remember, if delta H is greater than delta U, then delta Ng should be positive. Okay, and if delta H is less than delta U, then delta Ng should be negative. Clear? So I want positive delta Ng, and if I see option number 1, here delta Ng is what? 2 minus, here 2 minus 1 plus 1, 2, that is 0. So this is not the option. Here I can have 1, okay, and this side it is 0. So here it is 1. Okay, so that will give me option number B. Here I will have delta Ng as positive, option number B here. Okay, next, this is bond enthalpy question. Bond enthalpies of A2, B2 and AB are in the ratio of, so I have A2, B2 and AB. These are in the ratio of 2x, 1x, 2x. Okay, if the bond enthalpy of formation of AB, means if I want to form AB, then I have to form like this, right? So for 1 mole formation of AB, 100 kilojoule is required. So if I want to form 2 moles of AB, 200 kilojoule will be required. So 200 kilojoule will be equal to, minus 200 will be equal to bond enthalpy of A2 plus bond enthalpy of B2 minus 2 times bond enthalpy of AB. Okay, so what is the bond enthalpy of A2? 2x. Bond enthalpy of B2, x, minus 2 into bond enthalpy of AB, 4x. Okay, that is equal to minus x is equal to minus 200. So I will get x is equal to 200. So what is the bond enthalpy of B2? That is option number C. Okay. Okay, so please check, students, this answer. Okay, let's move forward now. Equilibrium. Okay, I'll be again telling the formulas of equilibrium that you should be knowing. So first of all, if I have a general reaction, A gives me B plus C. Okay, then what will be the K equilibrium for this one? That will be concentration of B to the power of x. So suppose this is like this, these are the coefficients. then b to the power of b, c to the power of c divided by a to the power of a. Okay. Now this is the equilibrium concentration or equilibrium constant formula. Now how can we use equilibrium constant to predict the direction of reaction? Now suppose the reaction is there, A gives me B plus C, okay, and at any point of time you can calculate QC. QC means what? The concentration is anything except the equilibrium concentration. The reaction is not at equilibrium. At that time we calculate QC, okay. So it is same, B to the power of B, C to the power of C and A to the power of A, right. Now if I calculate this one, and if QC is greater than KC, remember if QC is greater than KC, then reaction will go in backward direction, and if QC is less than KC, then reaction will go in forward direction. If QC is equal to KC, then the reaction will be at equilibrium, okay. Yes, Sunidhi, organic we will be doing tomorrow. What is the relation between delta G and K? Delta G is equal to minus 2.303 RT log of K. Okay. So students, I am just telling you the formulas because that is what you need to revise at this point of time. There is no time now to go deep into the concepts, okay. So please focus on the formulas of PU1 chapters that I am telling you, and that will help you to get good marks, okay. Next, stoichiometric coefficients and Kc. Okay, now see, suppose you have a reaction, A gives you B plus C, okay, and its equilibrium constant is K1. Suppose I reversed the reaction, that is B gives me now A plus C. So what is the K dash here? It will be 1 by K1. When the reaction is reversed, the equilibrium constant is taken 1 by K1. Now if you have a reaction, A gives you B plus C, and you are multiplying the whole equation with N. The first equilibrium constant was N, K1. Now when you multiplied with the whole equation with N, now the new K dash will be K1 to the power of N, okay. Next, if the reactions are added, so if you have two reactions, A gives you B and I have B gives you C. This one is K1 and this one is K2. Now if I add these two reactions, I will get A equal to C, this will get cancelled, and its equilibrium constant will be K1 into K2, okay, clear? Okay, is it clear students? Okay, next we will have ionic equilibrium, certain things that you should know, how to calculate or how to find out the conjugate base. Suppose I ask you to calculate conjugate base of anything, then what you have to do? Remove one H plus. Okay, remember conjugate base means you have to remove one H plus, and if I ask you to calculate conjugate acid of anything, what you have to do? Add one H plus. Okay, so please note down these formulas, okay. Yes, please note down these questions. Next we will see acid dissociation constant, okay, that is represented by Ka, okay. Ka, if it is very high, then acid will be strong, okay, and Ka, if it is low, then it is a weak acid, okay. Next what we have? pKa equal to minus log of Ka. Okay, these are some formulas I am telling that you should be knowing. Next I have pH plus POH is equal to 14. This relation you should know. Then I have pH is equal to minus log of H plus, and I have POH is equal to minus log of OH minus. So please remember these formulas, okay, very very important. Next we will have, okay, so next is we have buffer solution. So students, I am telling you the formulas, so please remember these formulas, that will be important. That is what you should be requiring at this point of time. No explanation, nothing is needed. Please remember the formulas and go for the exam, okay. Yes, now coming to buffer action. So listen, here we have two types of buffer. One is acid. So what is a buffer solution? A solution that can resist a change in the pH, okay. So we have acidic solution, acidic buffer and basic buffer. Acidic buffer and basic buffer. What is acidic buffer? How it is made up of? It is made up of a weak acid plus salt of weak acid and strong base. For example, if you take a weak acid like CH3COOH and a salt of this acid with a strong base, that can be CH3COONA. Okay. Next, basic buffer I can have, it is made up of a weak base plus salt of weak base and strong acid. Okay. So we have NH4OH plus a salt of weak base and strong acid, that is NH4Cl. Now to calculate the pH of acidic buffer, what is the formula? pH is equal to pKa plus log of salt by acid. Okay, pH of acidic buffer will be equal to pKa plus log of salt by acid. Sunidhi, I am giving you the formulas. I am in live, we are already there, so please note down these formulas with me. That will be more than enough, dear. Okay. Madhu, they won't ask you questions on definition, so please don't worry. Yes, so many hearts are coming up, so students, just let me know if you are liking this session. If you are enjoying solving questions, then do put down some like and all everything, so that we are motivated. Okay. Okay. Next, for a basic solution, we have POH is equal to pKb plus log of salt by concentration. Oh, sorry, one second. Just a minute, students. Just a minute. Okay, so there was a small error, sorry. So PaOH is equal to, one second. Okay, so yes, so POH I will write once again. POH is equal to pKb plus log of salt concentration divided by base concentration. Okay, clear? Okay, next we will move towards salt hydrolysis. Okay, so salt hydrolysis, you should remember, salt can be made up of strong acid plus weak base, or a weak acid plus strong base, or we can have a weak acid plus weak base. Okay, then what are the formulas of the salt hydrolysis? So you have pH here is equal to 7 plus half 7 minus, okay, just a minute, 7 minus half pKb, okay, minus half log C. Here what is the formula? If I have a weak acid, it is 7 plus half pKa plus half log C. Okay, then here I have 7 minus half pKb plus half pKa. Okay, please note down these formulas. Yes, Priyanka, this will be enough. Tomorrow we will have organic section, so if you do these two, you will definitely get 35-40 plus. Please do it now without any doubts. Okay, so I have already given you salt hydrolysis. Okay, now what is solubility product? Suppose I have a salt like this, AXBY. Okay, how will it dissociate? A X times of A and Y times of B, right? So for any salt of AXBY, the solubility product KSP will be equal to X to the power of X into Y to the power of Y into X to the power of X plus Y. For example, you have a salt like this, barium chloride. Okay, so here this is 1, so I can say X is equal to 1 and Y equal to 2. So it is 1 to the power of 1, okay, 2 to the power of 2, S to the power of 1 plus 2. So you will get 4S cube. Okay, clear? Okay, next Now students, please solve this question, all of you. Pavani, chemistry live class we are already doing, right? Yes, students, now please solve this question and tell me the answer. Yes, please solve this question and tell me. Yes, students, please solve this question and tell me answer. Pavani, this is chemistry live class going on. What are you asking? Please check. Okay. Ending time, yes. We are almost towards the end. Okay, just we'll discuss structure of atoms, some formula, and then we will wind up today's class. Okay. Yes. Can we solve this question, students? No more discussion, please. Don't do unnecessary chit chat in the comment section. You have come here to study, so please sit, do the questions, write down your notes, and focus on the class. Okay, don't get distracted, don't disturb others also. Okay. I am getting so many answers. Yes, I will upload the PDF, everyone, please don't worry, and I will take your all. We have just left with one more chapter, structure of atom, I will discuss, and then I will be taking all of your doubts, and then we will end the class. Okay, very soon we will end. I know it is very difficult to sit for a long period of time, so that much we will revise today. Tomorrow we'll do organic, and then we are done with our syllabus, right? Yes. Yes. Okay, so can we solve this? What is there? How it is related? Okay, so if I have the first equation, okay, equilibrium constant K1 and K2 are given. This is K1 and this is K2. Okay, you have to find the relation between K1 and K2. So suppose this equation is there. First, what is done? The reaction is reversed, right? If I reverse this reaction, NO will come on this side. So first I will reverse this reaction, that is NO2 will give me NO plus half O2. Okay, so that will become, I can write this, suppose this is K2, first that one will become 1 by K1. Next you are multiplying 2 to the whole equation. If you are multiplying 2 to the whole equation, you have to take power here. Then I can write that K1 is equal to, K2 will be equal to 1 by K1 square, but that is your option number D, right? Yes. I think D is the correct answer. Yes, Amulya, traveling with Karnataka, all of you are correct here. Next, conjugate base. I just told you how to find conjugate base. Those students who made notes now can answer me this question. If you want to find conjugate base of something, how to do? Yes, Bhuvan, inorganic also we will be doing. Okay, tomorrow we will be doing both inorganic and actually I planned for inorganic today also, but already 2 hours are over, so let's focus on physical today. Organic and inorganic both are theoretical questions. We don't have that many calculations, so tomorrow we will do both organic and inorganic. Okay, PDF will be uploaded in the WhatsApp channel. Clear, students? Now please answer this one. If I want to find conjugate base, what I have to do? Remove one H plus, right? If I remove one H plus, I will get NH2 minus, so that is why option number C. Okay. Yes, Safia, inorganic and organic will be doing tomorrow live, so please don't worry. Okay. Yes. Okay. Time, same time dear, 5 p.m. Tomorrow 5 p.m. we will have organic and inorganic classes. Okay. Next, can we do this question? Ka values are given. I told you Ka value higher, stronger is the acid. So you have been given the Ka value of H2SO3. Okay. H2SO3, HNO2, CH3, COOH and HCN. Okay. What is it? You have 1.3 into 10 to the power of minus 2, 4 into 10 to the power of minus 4, 1.8 into 10 to the power of minus 5, 4 into 10 to the power of minus 10. So, which of the following above acids produce the strongest conjugate base? Now here remember one very tricky thing. If acid is weak, okay, if acid is weak, then conjugate base will be stronger. Okay, if acid is very weak, then its conjugate base is stronger. So you have to find strongest conjugate base. That means you have to find weakest acid. If I want to find weakest acid, then the Ka value should be least, right? Out of this I can find the Ka value of HCN is least. That means it is the weakest acid and its conjugate base will be strongest. So what will be the answer here? That is option number D here. Okay, option number D. Yes, Saifia, we will do inorganic chemistry definitely, as I told you. Organic and inorganic we will do tomorrow. Okay. Next, can we answer this one? See, you are removing one H plus from the first acid. Then after that you are removing another H plus from this one. Okay, this should be actually H2A minus. Then you are removing another H plus from this one. So what is the relation between Ka1, Ka2 and Ka3? Yes. Yes. Can anyone tell me the relation between this one? So now you see here, when I am removing one H plus, I am removing from a negatively charged species. To remove one H plus from a negatively charged species, it will be very difficult. Okay, so that is why Ka2 and Ka3 values will be lower. Ka1 will be greater than Ka2, will be greater than Ka3. Okay. Next, we have been given with a weak acid and a weak base. Their pKa and pKb values are given. You have to calculate the pH of the resulting solution. So I have given you just now a formula. Those who have written the notes, they will be knowing 7 minus half pKa, 7 plus half pKa minus half pKb. Okay, so what will be 7 plus half? What is pKa value here? 5.9. right, minus half, what is pKb value? 5.8. So just solve it and tell me how much we will get. Knowledge games, it will be informed, dear. Okay, it will be informed to you at what time if it is there. Okay, so we will notify you, please do not worry. Okay. Okay, what will be the answer for this one? D. Those who are saying D, it is correct. Just I have already written the formula, solve it. You will get option number D here. Okay. Next question, solubility product question. This was a question of 2024. You can see recent question. Okay. Can we solve this? Solubility product of CaC2O4 at a given temperature is given to you as 4 into 10 to the power of minus 9. Solubility of CaC2O4. So if I see this is x is equal to 1, y is equal to 1 here. So what is the solubility product? 1 to the power of 1, 1 to the power of 1, s to the power of 1 plus 1. So that is s square will be the solubility product. Now Ksp is equal to s square. Okay. So what is the value of Ksp here? 4 into 10 to the power of minus 9 is equal to s square. So what is s value here? Root over of 4 into 10 to the power of minus 9. Now many students did a mistake here. Many of them went 2 into 10 to the power of minus 5. Okay, but you see, how will it be 2 into 10 to the power of 5? No, I can write it as 40 into 10 to the power of minus 10. Right now, if you see 10 to the power of minus 10 square is, or it will be minus 5. 40 square, 6 square is 36. So it will be 6 point something. Okay, so you can see 6 point something into 10 to the power of minus 5. Okay. Amulya, same time, 4 p.m. Maybe at 4 p.m. or 5 p.m. we will inform you. So just be put the notifications on for this channel. You will get notified. Okay, we will schedule it and we will let you know. Okay, most probably at the same time. Okay, next we'll go to the last chapter, that is atomic structure. Okay, so first of all, what you should be studying for atomic structure? The hydrogen spectra. Hydrogen spectra, what does the formula? That is wave number, or 1 by lambda is equal to RH into 1 by n1 square minus 1 by n2 square. This formula is the first thing that all of you should be knowing. Now here, based on n1 and n2, we have how many types of series? We have 5 types of series: Lyman, Balmer, right, Bastian, Brackett and P-Fund. Okay, so here n1 and n2. So for Lyman, n1 is equal to 1, n2 can be anything. Okay, so for like this, it can be, here it can be. So students, please write down the formulas with me. This is and we will have, okay, so this will be the, okay, so this will be the values, the series name or the series will be there. So all of you please remember this series, this is very very important. Okay, fine. Next, what is there? All of you wrote this formula. I'm just telling you what all things you need to focus. See, this is a PU1 chapter. Hardly 1 or 2 questions will be asked. So you don't have to go very in depth of the topic. You just have to focus on what I'm telling you at this point of time. Next, we will know what is the formula to calculate angular momentum. Angular momentum is represent like this: mvr is equal to nh by 2 pi. Okay, this is the formula to calculate angular momentum. Please write down this one formula, all of you please write down. Please note down the formula quickly. Yes, let me see your comments. Okay, just a minute. Here a small mistake. I add. Okay, this is the formula. Please correct it, students. Hi Suresh, hi everyone. Okay. Yes, Divyashri, just few more questions. We will end it in 10-15 minutes. Okay. Next, what is de Broglie wavelength formula? Lambda is equal to h by p or h by mv. Okay. So please note down the formulas. H is what? What's the value of h here? 6.63 into 10 to the power of minus 34. Clear? Next, what we have after that? Uncertainty. What is the formula for uncertainty? Delta x into delta p is equal to h by 4 pi. Okay, or you can write delta x into m into delta v is greater than h by 4 pi. Okay, next what I have? Photoelectric effect. What's the formula? H nu equal to h nu 0 plus half of m v square. Okay. Yes, Anisha. Okay. Next we will see quantum numbers. Okay, what all quantum numbers we have? So for example, I have n is equal to 4. Okay, this is the principal quantum number. What does principal quantum number tell? It tells you about the energy of the shell. Okay. Now after principal quantum number, we have next quantum number, that is your azimuthal quantum number. Okay, from quantum numbers many questions are asked. Okay, azimuthal quantum number, it varies from 0 to n minus 1. Okay, the value varies from 0 to n minus 1. It is denoted by symbol L. Okay, 0 to n minus 1, it is denoted by symbol L. Next, what we have for this one, you have 0, 1, 2 and 3. These are the azimuthal quantum numbers. Okay. Next, what we have here magnetic quantum number. Magnetic quantum number denoted by ML. Okay, and what is the value of this one? Minus L to plus L. So for 0 it is 0, from here it is minus 1, 0 and plus 1. Here it is minus 2, minus 1, 0, plus 1 and plus 2. Here it is minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. Okay. Next, this is denoted as S, this is denoted as P, this is denoted as D, this is denoted as F. And what does azimuthal quantum number tells you? About the shape of orbital. Shape of orbital. And what does magnetic quantum number tells you? About the direction, or you can say, yeah, direction of orbital or orientation of the orbital. Okay. Okay. Let's go to the first question. So students, we are just left with 3-4 questions. Let's solve it quickly. Yes, shape of the orbital. Yes, Nagavani, you are correct. Now please solve it. Orientation of the orbital. Okay. Yes, can we solve this question? If the wavelength of the photon is given and h is given, then the momentum. Okay, so what is the formula? We have lambda is equal to h by p, right? Momentum is asked here, so that is h by lambda. What is h value? 6.6 into 10 to the power of minus 34. What is lambda value? 2.2 into 10 to the power of minus 11. Okay, so it will be 3 into 10 to the power of minus 23. Okay, so that is 3 into 10 to the power of minus 23, option number C. Yes, all my children are answering very well. Happy to see that. Next question number, can we try this question? Two particles A and B are in motion. If the wavelength associated with A is 33.33 nanometer, the wavelength associated with B, whose momentum is 1/3 of A. Guram, this video we are doing physical chemistry only. This video is enough for physical chemistry. Tomorrow we will do organic as well as inorganic. Okay. Unknown, you can take any color, doesn't matter here, but I prefer black will be good. If I would be there in place of you, I would have taken blue, but any color you can take, doesn't matter. Okay. Okay, so students have been answering here D, Adu Gaming, UI Daniel, Crazix. Okay, okay, let's see the question. See, suppose I have two particle A and B. Okay, what is the wavelength of A? That is 33.33 nanometer. Okay, I have to find out wavelength of B. Next, PA is what? The momentum of A. Let it be PA. What is PB? 1/3 of momentum of PA. Right, now if I put lambda A by lambda B, that is equal to h by PA, okay, divided by h by PB. Okay, now I can just substitute h I can cancel. Lambda A value is 33.33, okay, divided by lambda B into PB is equal to what? PB is equal to 1/3 PA divided by PA. Okay, so it will be how much I will get? Lambda B, okay, 99.99 nanometer, or I can write it as 99.99 into 10 to the power of minus 9 meter. Okay, now how can I just write out in the more scientific form? It is 9.9 into 10 to the power of minus 8, right? Now 9.9 is equal to 10, right? Almost I can approximate it to 10 here. So I can write this one as 10 into 10 to the power of minus 8. So it will become 1 minus 8, that is minus 7. So I will get 10 to the power of minus 7, and that is option number D. Okay. Yes. Next, can we answer this, students? This question can we answer? Very simple question. Consider the following set of quantum numbers. Which of the following is not a permissible arrangement of the electrons. Yes, not a permissible arrangement of the electrons. Nisha has already answered D. Yes, Nisha, you are absolutely correct. See, if L value is 2, then ML value can be from -2 to +2. It cannot be -3. So, it is not a permissible amount, okay, or permissible value. Okay, just a minute. Okay, next. Can we have this one? The two electrons have the following sets of quantum numbers. Which of the following statement is true? Now see, always which is having more energy, if I want to calculate, I have to take n plus L value. The one whose n plus L value is higher, n plus L value is higher, okay, that will have more energy. Okay, that will have more energy. Now if I say for this one, P, n plus L value is what? For P, n plus value is 5. And for Q, what is n plus L value? 3 plus 0, that is 3. Right? So I can say that P is having greater energy than Q. Yes, option number A is the correct answer. Yes, Manoj, you will definitely get. Okay. Okay, students, so I just want to discuss few more formulas from this chapter. Okay, just note down here. E of any orbital, okay, any orbital E will be equal to minus RH into Z square by N square. Okay, minus RH Z square by N square, and Rn means any orbital radius will be equal to minus A naught, sorry, not minus, A naught into N square by Z. Okay, A naught into N square by Z. Here what is the RH value? RH value can be minus 2.18 into 10 to the power of minus 18 joules, that is one value. And next I have minus 13.6 EV. Okay, so two values are given. These are the values of RH. Okay. Okay. Mahesh, the answer is option number B. Okay. Okay. So, students, this chapter is atomic structure, or you can say structure of atom. So students, we have done the revision of entire physical chemistry, and I hope that you have also done with me, right? Tomorrow I'll be giving you the time very soon, so please turn the notification on so that whenever the class is live, you will get the notification, okay? So tomorrow I'll try to complete organic and inorganic, especially the organic, because many students have doubt in organic. So we will be doing that, do not worry, and that's all for today. And students, please don't worry, I trust all of you. Your preparation will go super. Your exam will go, like, you will be doing very good in your exam. So please, 2 days are left, right? So please calm down yourself, don't get too much panic. If you haven't studied anything, okay, just go and watch our top 30 videos, top 30 questions series. We have discussed so many questions, so just do question practice, nothing else, okay? And those students who are preparing really well, for them also I want to advise, at this point of time, don't take anything new, just keep on revising the chapters, okay? Yes, students. Okay. Pavani, ma'am, is there live class for physics and maths also? So dear, that will be notified. It's not yet confirmed. It will be notified. Okay. Okay, students. Yes, so that's all, students, and I hope the class was helpful. Just do let me know how was the session. Did you enjoy? Did you learn something or not? Did you make notes out of this or not? Please, and show me some of your love through putting the heart sign, and just tell me how was the class. Yes, Comet K Physics. Okay, Crazix, thank you, dear, thank you so much. Tips for 2 days. So Aditya, in the last 2 days, you just have to focus on PU2 syllabus. Okay, that's what I'll tell you. And do not read anything, just watch our top 30 videos, or if you have any books, just do question practice, okay? But don't worry, just do question practice at this point of time. Thank you, Soumya, love you too, love you so much. And then we have here Manoj, yes. Yes, to love you all students. You all are so supportive throughout the session, throughout this journey, and really we love you all. Okay, all the teachers love all our students. So yes, definitely. Manoj, what is your question? I have not read your question to reply. Okay, so I can see so much hearts coming out here, so I hope the session was helpful. Hi Queen, hello. Yes, XYED, you can expect similar type of questions, not same, but definitely similar questions. Okay, so Shahid Asgar, these are the important questions. These type of questions are important, so please do practice these questions. Okay, yes. Pikachu, ma'am, any tips for Comet K physics? So dear Comet K physics, I am a chemistry teacher, but still I will be telling you, just focus on PU2 chapters and do last previous year questions first. Okay, thank you so much Suchitra. Yes, okay. Sania, bless you dear too, and yes, definitely you all will get good rank. I am very sure about it. Okay, because we have been working for a long time. It really helped you. That's great to know. Okay, fine students, that's all. See you tomorrow. Time will be updated, so please put down in your comment section, in the main comment section, how was the session. Okay, that's all. Bye bye, take care all of you, and please study hard. Let's crack KCET in the next 2 days. Let's put all our efforts, 100% of our efforts we should be putting out at this point of time. Okay, yes believer, we love you all. We all teachers love all of you. Okay, thank you so much. Thank you everyone. And yes, bye bye students. Please take care and go back to study. Thank you. Bye bye.